Hi everyone, welcome to lesson 3.2 on page 29 of your Springboard books. We have a relatively short lesson today, but a very important one to get us ready for some more stuff tomorrow. So make sure you take good notes today. Now, two things that we're going to talk a lot about today are talking about finding the hypothesis and the conclusion of a conditional statement, as well as talking about counterexamples of conditional statements. Now, the first thing you're probably saying is, what is this conditional statement thing? And what a conditional statement is it's a statement that is written in an if-then format. So, for instance, if this happens, then this happens, okay? Conditional statements don't necessarily have to be true statements. They're just written in an if this happens, then this happens format. And what we like to say is if P, then Q, right? This is an example of a conditional statement format, if P, then Q. The hypothesis is the P portion, the if this happens, while the conclusion is the Q portion that comes after the word then. Your hypothesis, again, the trigger word is if, and it does not include the word if, it's just all the phrasing that comes after that. Same thing with the conclusion. It does not include the word then, that's just the trigger word, it's everything that comes after that, okay? So for instance, in example A, our conditional statement is if 3 times x plus 2 minus 1 equals 5x plus 11, then x equals -3. Well, the hypothesis, again, is going to be all that piece that comes after the word if. Here's if, the hypothesis then is all this phrase after, and then again, our trigger word for the conclusion is then, x minus 3 is the, x equals, -3 is the conclusion. Okay, so the next example here says, using the conditional statement, if x plus 7 equals 10, then x minus 3, or then x equals 3. Well, again, the hypothesis comes after our trigger word here of if x plus 7 equals 10. So the hypothesis is x plus 7 equals 10. Again, notice I did not include the word if. The conclusion then comes after then, and that's going to be x equals 3. Now, the property that's going to allow this hypothesis to turn into the conclusion, if you remember from yesterday's lesson, is going to be the subtraction property, because we can subtract over that positive 7 to get x equal to 3. Okay? Now, sometimes you are going to see these slightly switched around, that it's not always going to be in an if-then format, but we can rewrite them so that it is in an if-then format. So take special note of this reading math box to help us do that, so we can properly put the P's, the hypothesis, and the conclusions, the Q's, in the right spot. So for instance, notice here it says, I'll go if you go. Notice when it's put that if in the middle there, it's going to be Q if P. So this is actually going to be the Q, the conclusion. The part, again, after the if is the hypothesis. So to rewrite this as a conditional statement in if-then format, we would write if you go, comma, then I'll go, that Q portion, okay? Now, in the next example, again, it says there is smoke only if there is fire. So if we, again, check out our example here, only if is going to be a P only if Q statement. So here's our Q, here's our P. So we would say if P, if there is smoke, then Q, then there is fire. Last but not least on these examples, we have P implies Q. Notice the word implies here. So here's P, here's Q. P implies Q. So if x equals 4, then x squared equals 16. Okay? Very important that we can identify our P's and our Q's. Now, the last part of the notes here today is the idea of a counterexample. So, because we can state if this happens, then this happens, but it might not necessarily be a true statement. So if the hypothesis is true, but the conclusion is false, then we would say that there is a counterexample possible. So notice here we have a conditional statement. If two numbers are odd, then their sum is odd. So we have a hypothesis, if two numbers are odd. We have a conclusion, their sum is odd, but it's not necessarily true. Okay, the hypothesis is two numbers are odd. Our conclusion is our Q. Their sum is odd. But there's a counter example for this, because if I add two numbers together, for example, 1 and 3, their sum is not odd, it's even, right? 4 is an even number. So this would be an example, a counter example to prove that this conditional statement was in fact false. Okay, try your own example to prove that two odd numbers do not sum to be an even number. All right, thanks everyone.